Hello. So let me give you whole overview of the program, like the Arduino embedded code. So starting from the imports, we will be using four imports. Software serial import is used for basically communication between the GPS device, basically SIM808, and the Arduino. Basically, we have used it here. So what it does is that we have connected on port number 10 and 11. One is for transmission pin and one is for receiving pin. They are named as TX and RX on the SIM808. You can look on the SIM808 circuit diagram to see what is like the TX pin and RX pin. Basically, it is connected on 10 and 11. In the diagram, I will be showing you later that what is what. So, software serial is used for that. Arduino JSON is used to create a JSON-like document. Let me show you where we are creating that. So, Arduino JSON. Yes, so here we are creating a JSON document of 256 bits, no 256 bytes. It has external ID, P, sensor ID and value. So external ID is like I'll explain it later, but here we are creating the JSON document, and for that we are using this import, this one, and gravity TDS. So basically we use gravity TDS for digitally calculating the TDS value. This is what gravity TDS is used for. I have another code for like analog computation of TDS value, but we are not using that here. Analog computation is used in only in ESP32 or different architecture. For Arduino, we have a library through which we can calculate TDS easily, so I am using that only. Similarly, for DST11, the temperature and humidity sensor, like for computation of temperature and humidity sensor, we will be using DST11. So, like we have the library here, we'll be using this. Now these are the macros which we'll be using. Like I have basically set uh, the like data pins. Like Arduino has data pins and analog pins. So I have defined the data pins which we'll be using here and the analog pin which we'll be using here. Two more data pins are there, like 10 and 11, which are not mentioned here, but like we can add the macro here also, like what is the TX pin or what is the RX pin. So that will be helpful in future. So this reset function is used to like programmatically reset, like programmatically like we have to restart the Arduino. So we can use this to like programmatically restart it. Like we will just call reset function and it will restart the Arduino. So that is how it can be done. And now this is the like we have created an instance of software serial through which we will be sending the network commands to SIM808. Like we'll be using my serial, or we can rename it in future, but for now it is my serial. So we'll be using this to like uh, send the network commands to like SIM808. Fine. DST11. So we have imported DST11. So we are creating an object of DST11 class. Similarly, we have created an object of software serial class here with these parameters. Now we are creating object of DST11 class. We'll be using this to like get the data from DST11. DST11 is selected at D4, like data fourth number of data pin. Now gravity TDS. So gravity TDS is used for TDS calculation, and we have created an object of gravity TDS class Now we'll be using this gravity TDS to like get the TDS value. Since I'm using the Airtel SIM, so I have set my APN as airtelgprs.com. Like you have to set, like if you are using BSNL SIM, then you have to set the your GPRS APN as something dot like bsnl.com or something like that. You will have to Google that. You can easily find that. And we are not using GPS user GPS password. This is meant for those sims which are which have set up their pin. So, but we are not having that, and I think we'll not be using this in future also. Like if we want to restrict the user so that that particular SIM can only be used in this device only, then we can set the GPS user and GPS pin for the uh, SIM, and in future, like if the user removes that pin and put in other device, he won't be having that pin, so he won't be able to use that user of SIM. So like only our device will support that SIM. So we can create that restriction in future, but for now it is fine. This variable failed. Failed is for how many times the data was not sent successfully. So we are keeping a count of that, and in our code, like there is a check that if the count is greater than 10, then the sim will be restarted. Like the whole sim module will be restarted. We have set up relay through which we are restarting the sim model. So I'll be showing that later. Yes, this is the part where we are restarting the sim. So sim80 startup sequence, what this does is, first it sets the relay to low. Basically, we have set the we have connected the relay to normally open. So what this does is that our connection is normally live. Normally the connection is live, and when we set as low, the connection is turned off, and for a second, like it is turned off for a second, and then it is again turned to, like it is set to high. So basically we are setting the relay as low for at most a second, and then we are setting it to high. So basically we are turning off the switch for about a second, and then we are turning it back on. Um, this startup pin. This pin is used to basically like say startup pin. So yes, startup pin is connected on data 7. So this is used to connect to the SIM808 D9. There is a section D9 in SIM808. We have a if we connect if we give it high, then we don't have to manually press and hold on the like SIM808 startup button every time we start the SIM808. So we avoid that by using this. So this makes the whole SIM808 startup automated. So by using this, we can automate the whole startup sequence process. So we are initializing the serials, the my serial, that was this one, SIM808, through which we will be sending the communication network communication commands. This is here my serial, and the serial is the like what we'll be seeing on the console. Like if you see, this is a serial monitor, and here we can see the serial data, right? So we are seeing this on the serial console, and this is what the serial dot begin is for, and my serial is for the network commands, to sending network commands to SIM808. Now we are initializing the pins, since we want that we want to like see the output, if the data is sent or not, without the serial console. So I have set up a few functions through which we can see. I have basically connected an LED pin to I think what was that, 213th. So basically I have connected one terminal to 13th and one is to the ground. So whenever like we set the DLED pin high, the LED will turn on. So I've used that to like see if our data was sent successfully or not. I will explain it later. So this is an output because we are sending it, like we are sending the output, like setting it as high or low. So that is that. And the tilt sensor pin, basically we will be getting the output of the tilt sensor. So tilt sensor will be sending us some data. So this is an input pin because we are receiving that data in the Arduino. So that's why it is an input pin. And relay pin, like as I explained, it is to turn off and turn on the SIM808. Startup pin is to like after it is turned, like after the SIM808 is turned on, we want that to be like, we don't want to press the SIM808 startup button. We like hold it for 1 second. We just want it to be automatically started. So for that we are using this pin mode. Like we can send high for a second and the whole SIM808 will be started automatically. Now we are slicing the sensors. For gravity TDS, we like we have to set, like we have to initialize it. So we first set the TDS sensor pin, like what is the TDS sensor pin, and here it is A1. We set the reference voltage, like it will be sending 5 volt to TDS sensor. So we have set that. ADC range is basically what will be the range from 0 to 1024, like that will be the range, like 0 to 1023, like a total of 1024 range will be having. uh, and we have like we after setting these, we are starting the TDS sensor, like, and now we can fetch the data like whatever TDS sensor has. So we have started the sensor. For GPRS, we have to like initialize it. So we first send the AT command. AT command is like we are broadcasting it to the like our tower, like nearest tower. That okay, we want to make a new, like we want to make a connection to the tower. Like basically we are reporting our presence. Okay, we are here. So you know that like we'll be making few requests. It can be anything. Basically we can send SMS, we can send call request, we can send GPS request or anything. So like we are just basically sending that okay, this is our presence and you know like we are here. Now we are sending them that okay, now you know that we are here. So we are attaching a GPS network, like we will be in few of the moments we will be like sending you few data. So like you get ready to receive those data and process our request and return us our response. So that is this command AT plus CG ATT. Okay. Now this is the setup phase. So basically setup phase is for like this will be run once the Arduino is started. So basically I have showed you init serials. Init serials is this function. Then we run the SIM808 startup sequence. SIM808 startup sequence is this function. Then we have what's that? Init sensors. Init sensors was this function where we are initializing gravity TDS. And then we have init GPS, which was this function. We are basically sending our presence and attaching to the GPS network. Now this is the loop function. Basically what the loop function does is like run it multiple times, like say till the Arduino is running. Like run it till the Arduino is running. So it will keep on running. Say I have initialized variables for where our data will be stored, and using this parameter, like this, I am reading the like various sensors data. So how this is done? So basically, say I want to read DST11 data. So I have created one function, read DST11 data, and in this I'm like calculating the DST11 data and setting it the temperature variable and humidity variable. So basically, I am typecasting it the temperature to temperature. Like I am setting the DST11 temperature. So basically, what I have received from the DST11 module, I am setting it to the our local variable and passing it to this variable. Now this variable holds the data, so we can send the data to the server. So basically this send data needs two parameters. Like first let me tell you um, how you can modify like the various parameters. So say okay. So say if you want only DST11 data, then you can just keep this and remove all the other parameters. Just keep in mind that if you remove those, then you have to remove from here also. Like just keep those data only which you want to send. So like if you are reading that data, then you can send it. So basically, say you are only reading TDS data, so you will remove this part and other part also, like till the end. Since you are not reading anything else and not sending it to the server, so you can remove these also and these part also. Fine. So how the send data is working? So basically we have a mapping of sensors and like their ID. Basically we are sending the data through ID. So like this is the temperature value and this is the sensor ID. So we have a mapping of sensor and sensor ID. I will provide it later in the documentation. So you have to use that mapping to send particular data to the particular sensor in the backend. Okay, and this will be sending temperature, then this will be sending humidity. Like it will run and run like in loop multiple times, not in loop. And once this is done, this will check how many times it has failed. So if the failed value is greater than 10, then it will again start the simulates rate. We can have we can start like restart the whole Arduino. I think that will be also an option, but simulates rate fixes the problem, so we can use this. But we also have option to like restart whole Arduino using this function. There was a reset function. You can just call the reset function and that will restart the Arduino. And we are pausing for like 3 minutes between the readings, and through this like we can this is whole loop and this will run like again and again after like 3 minutes. Like this will run and it will wait for 3 minutes, and this will again run and again wait for 3 minutes, and again wait for 3 minutes. Now we have we are collecting data for sensors like tilt sensor. So basically I have created a function for each sensor. So each sensor like you have value, and like we are passing the variable as reference, so the whole value is set in this variable, not as local variable. So you can keep that in mind. And we are just reading what is the value of the tilt sensor and just setting it in the value. So this is how the data is propagated, and like we are printing it on the console. So like if you see, we'll have it somewhere here. Yes, this is the whole data, humidity, TDS, pH, right? So this is how this is working. Similarly, we are reading for analog, and similarly we are reading for like this is for capacitive soil moisture sensor. This is for resistive soil moisture sensor. Both have different working principle. Resistive will have corrosion in future, but capacitive can work in various kind of environments, and it will not have any corrosion. But we will have to test it in future, that do this have any corrosion or something like that. So DST11 data, we are collecting the DST11 data. We have temperature and humidity. We are setting the temperature and humidity from the data we are getting from the DST11 module. Um, then the pH data, like the pH calculation is done manually. So I'm also not sure. This is this is I have referred a website, and through this like I have tested it. Like I have calculated it for the water that I was having. I'm not sure if this is totally accurate or not, but like we'll have to test it first in lab environment through like using various type of liquids, basically like uh, lemon water or something like that. Lemon water will have acidic nature, and uh, soap will have basic nature. So we can test that and see if it is changing or not using this function. If it is changing, then we can like assume that this like pH calculation is correct, or we can have litmus paper test through litmus paper, and then test through this function, see how much difference is there, and we can further calibrate it. Like we are adding the calibration value, so calibration value is 21.34. So basically we can increase and decrease the calibration value based on the readings we get from the litmus paper. Right? So for now you don't have to change anything. Just keep in mind that you can use these functions like just how I have used it here. Alright. This is for pH data. This is for turbidity data. We are also like manually calculating the turbidity. So basically, how we are calculating the turbidity, we are like calculating the sensor voltage, and through the sensor voltage, we will be manually calculating the NTU or turbidity. The unit of turbidity is in NTU. Basically, it is the turbidity is like how much light has passed through the sense like with the water. So on one side the sensor is emitting infrared light, and on the other side it is emitting like it is not emitting, it is receiving the infrared light, like how much it has received, and through that it is calculating the voltage. So this is how it goes. um, this function is used, I think here it is basically used to like rounding the function, like rounding it to the two decimal place, or like how much we define, like it will just round. And here we are just like reading the TDS data. So we are using the gravity TDS package and getting the TDS value, setting in the TDS value variable. Now this is our connect to GPRS function. Basically this function is called whenever we are sending the HTTP request. Like let me show you, like I'll show it later. So this sends the like this command to the SIM808, then this command, then this command. So as you see, like we are sending the content type at GPRS. So basically we are after we have initialized the network initially, like let me show you. Yes, this one. Here we have like notified the tower that we are here in this network, and here we have initialized the like GPS network. Then we are sending our like started sending our GPS content, like content type. We have tell the server that okay, we'll be sending like we are sending GPS content, so this is our GPS content, and then we have started sending the like we have said we started sending the APN. Like what is the GPS APN? Okay, so Airtel will be like Airtel can only use Airtel's APN, right? So we have set the like APN manually. Like we have to set it manually. We cannot do it dynamically. Uh, so we have set the APN, and you have to send this command also. I think I don't know what is it is for. Then we are after GPS is initialized, then we'll be initializing the HTTP, like hypertext transfer protocol. We'll be initializing that, and this will be the start of our actual communication. First was the network communication, then we will be sending the actual like what will we want to send as the like. This AT plus HTTP para. This is like basically telling the server that okay, what we want to send. Like, is it a post request or is it a get request? This is like this command is for that, and then this is the parameter we want to send. Like this is basically the URL that we want to send. So this is our server's IP, and we are sending the request to the API/API/data. We cannot make HTTPS request using SIM808, so we have to use the IP only. Otherwise, it won't be working. And then we are sending the like content. We are sending the content of the like actual content. So this is our app. Like we are sending the JSON request. I have showed in the starting that we are creating the JSON document. So we are sending the JSON request. So basically we are telling the server that okay, we are sending the JSON request. So like we are mentioning that here, and this is our HTTP data, like what data we will be sending. And if you see, we are passing the data here. So data will be of type string, and we'll be like adding that here. First we'll be measuring its length, so the server will know okay, this is the length of the data. Then we are just sending it and reading the response. After we have read the response, we will terminate the connection. Okay, and okay, now these functions ignore serial data will just like see, we are using ignore serial data multiple times. Ignore serial data will not print anything in the console, right? Like not in the my terminal, but in the terminal of like SIM808, because it will also be sending multiple response back to us. So we don't want those, because we are like we are checking the response in SIM8 like read serial data. So we want the response which we have received here only, read serial data. Like what was the response after this action? Like was it 200, was it anything else? If it was 400 or 500 see, if it was 400 then we fail to send the data. Like anything else than anything other than 200, we have failed to send data. Like see, uh, 200 response. So 200 means we have successfully sent the data and created an object. Other than that, like it has failed to send the data, and we are checking that. Like you can see, read serial response, and in this, like, we are checking the status code. If it is 200, we are setting the status as true, and if the status is true, otherwise it is false. Like, and here we are checking the status, like if the status, like this will return a status. I think send HTTP request, return status. Yes, here is the status. So basically we have initialized the status, go status, and we are passing the read CL data, like status here, right? So as you have seen, like, let me show you. So we are setting the status through true or false. Now we are checking the status here. Was the status where was that? At the bottom, like, it will return the status. So if the status is true, that means the data was sent successfully. It will also call the fast blink LED. So fast blink LED is like basically blinking the LED for 10 milliseconds. Like, it will turn on for 10 milliseconds and turn off. Slow blink LED is the data was not sent successfully, and it will like blink for a longer period of time, like about 1 second, and it will also increment the count of failed. So if the data was not sent successfully, so this is how we are doing. And here we are like creating the JSON document through which we will be sending our data. So this is our document, and like we are typecasting it to this string data type, and then we are passing it to the send HTTP request. Send HTTP post request will have data, and we are using this data and attaching it here. Okay. Now only two functions are left. So this is just for like visualizing was the data successfully sent. If the data was successfully sent, then you will see the blink, like LED blink, uh, like for a very short duration. And if the data was not sent, you will see the LED blink for a longer duration of time. Alright, this is the same data disconnect from GPS. We are calling the disconnect from GPS once the data was sent. Basically this will call this network command, and this will disconnect from the GPS network. Like from, like in the starting phase we have, I think, initialized it. Now this is disconnecting it. Alright, I think everything is done. Speak serial data is like, I think I'm using, no, I'm not using this. This will just print the like whatever response we have. Like here we are ignoring it. Here we are printing it, like whatever we have. So this is for that, and I think everything is done. Yes, thank you.